Hello, Mrs. Lovett again. I am out Wednesday morning, so my first block can watch this video for at least their first paper, and then they can work the rest of the papers that the substitute gives them on their own. But feel free to refer back to this video on Google Classroom with your earbuds if you need help. So we are doing things we've already done before. We've estimated, we've used area models, we've used the standard algorithm, and we have checked for reasonableness. So we're just doing more of that. And we're going to start with our factor 22 times 2 4/10. So we're going to round to the nearest 10, underline the 10, look to the right, 4 or less, let it rest. So 22 rounds to 20. And then 2 4/10, we look at the nearest 1, underline it, look to the right, 4 or less, let it rest. So it's going to estimate to 2. So 20 times 2 is, feel free to answer out loud, 40. So we know that our product needs to be close to 40, not 400, not 4,000, not 440. So now on our area model, let's put our tenths on the top. So 2 4/10 we can also write as 24 tenths. So we can break that up into 20 tenths plus 4 tenths. And then our whole number here, 22, I'm going to break that up into 2 ones, 2 tenths. So 20 plus 2. So 2 times 20 is 40 tenths. And then 2 times 4 is 8 tenths. So that gives us 48 tenths. Now if we stay in tenths, because we have tenths up here, 20 times 20, that's 2 times 2 is 4. Bring that 0 over and that 0 down, we have 400. And I'm marking them out as I go now because I noticed on the test that sometimes we either had too few or too many zeros. So mark them out as you go. Now 20, erase that mark, 20 times 4. So 2 times 4 is 8, and then that 0. So we have 480 what? Tenths. Because our unit is tenths. Now when we solve using the standard algorithm, 24, we can put tenths out here. So we're taking out the decimal. Times 22. We solve using the standard algorithm like normal. 1's place, 2 times 4, 2 times 2, 10's place, drop the 0, 2 times 4, 2 times 2. Add our two partial products together, and we get 528 tenths. And we know that we need to, if we were to write this in standard form, it'd be 52 8/10, because our decimal has to show tenths. To check reasonableness, 52 is close to 40. It is not close to 528, so we know that we have to put the decimal in to show tenths. So 52 8/10. When we did this before, we kept the decimal in its place, and we just remembered if we have one place over in our factor, we need to have one place over in our product. We do not need to put the decimal down here. It just needs to go in our final product. Okay, so now B is 3 1/10 times 33. So first thing we're going to do, estimate. So squiggly lines mean estimate. 3 1/10. Look at the, underline the whole number, look to the right, 4 or less, let it rest. So the whole number is 3 times, underline the 10, look to the right, 4 or less, let it rest. So 3 times 30. Multiply the two digits that are not zeros. Bring down that 0. Our product should be close to 90. Not 9, not 900, but 90. So now standard algorithm, no, not yet. Area model. So if we have 31/10, that's another way of saying 3 1/10. 31/10. So 30 plus 1. We need to make sure we label tenths. Times 33. So 3 times 3 is, bring down that 0, 3 times 3. So I have 93 tenths. And then erase that mark. 3 times 3 is 9. Bring over that 0, bring down that 0. It's 900. And then 30 times 1 is 30. So I have 930 tenths. The unit is still tenths. Now standard algorithm. 31 tenths. We're taking the decimal out. Times 33. Multiply the ones place first. Drop the 0 to go to the tens. Add the two partial products together. And we get 1,023 tenths. So if we put our decimal to show tenths, 102 is close to 90. If we did not put our decimal in, and we just wrote 1,023, that would not be a reasonable product when we already estimated and said that our product would be close to 90. So that's why it makes sense to have your decimal here to show tenths. Okay, number 2. Estimate. Then use the standard algorithm to solve. Express your products in standard form. So no area model on these last two. So 3 2/10 times 47. Underline the ones place, look to the right. That is going to round, oh, that's messy. That is going to round to 3. Underline the tens, look to the right. 5 or more, raise the score. So that's going to round to 50. So 3 times 5 is 15. Bring over that 0, it's 150. That's what our product needs to be close to. So now standard algorithm. 32 tenths. We're taking the decimal out, writing the place value here, the unit. 32 tenths times 47. Ones place. 7 times 2. 7 times 3 plus 1. Did I say tens place? I forgot what I said, but that's the ones place. Now we're going to the tens place. Drop the 0. 4 times 2 is 8. 4 times 3 is 12 plus 1. What did I do wrong? I did something wrong. 4 times 2 is 8. See, I added from my previous, I needed to erase that or mark it out. It's always good to be able to find your mistakes. I'm going to back it up a little bit and just double check. 7 times 2 is 14. 7 times 3 is 21 plus 1 is 22. Mark that out. Go to the tens place. 4, drop the 0. 4 times 2 is 8. 4 times 3 is 12. There we go. Add the two partial products together. Now, that's not 1,504. It's 1,504 tenths. So, see, tenths. So I need to put that decimal to show tenths. And yes, 150 and 4 tenths is close to 150. 1,504 would not be close, so that is why you must put your decimal in. Okay, last problem. Let's see if I can do this without any mistakes. B. And yes, I'm outside, so we can hear some doggy sounds. Frankie's out here sunbathing on the deck. Are you having fun, Frankie? She's listening to a lot of math. Are you going to make some noise for the recording? Nope, she doesn't feel like talking right now. So 3 and 2 tenths times 94. Estimate. That's going to stay 3. That's going to stay 9 or 90. Multiply. Bring over that 0. So 270. Our product should be close to 270. Now standard algorithm. Take out the decimal. 32 tenths. Write the unit. Times 94. Start with the ones place. 4 times 2 is 8. 4 times 3 is 12. Now the tens. Drop the 0. 9 times 2 is 18. 9 times 3 is 27 plus 1. Add the two partial products together. Our product is not 3,008. It's 3,008 tenths. So we need to make sure our decimal shows tenths. Actually, I'm not going to put it there since we have the word. I'm going to rewrite it as 308 tenths. And 300 is close to 270. This lesson is showing you why you put the decimal in. Not just showing you the standard algorithm and saying one place over, one place over. Showing you why. For that understanding of the unit and estimating for reasonableness. So good luck on the rest of this on your own. Make sure you turn in all your papers with your name on it before you leave class. See you later.